look at the lead code problem frog jump. So this problem is categorized as a common Google phone coding interview question. So this problem is a little bit difficult to understand, and I'll try to simplify it. So essentially for this problem, you'll be given an array of stones. So these values represent the stones which are present at fixed positions across the river. So when a frog can jump on one of these stones, and we need to check if there's a way for the frog to reach all the way to their last stone. And so they're given us a few rules, and that is that whenever a frog does a jump of k units, the next jump can only be k minus 1, k, or k plus 1. And also they have said that they can only jump in the forward direction, and in the first stone, they must be like only of 1 unit. So yeah, let me try explaining. So for problems like this, the best way to solve is first, write down the problem, write down the integer array, and try to figure out, what will be the easiest solution, like given a small array of numbers. And that way you can, help us to determine the solution for larger arrays. And problems like this, you're expected, they're a little bit vague, and the reasoning behind it is we want the candidate to ask questions to the interviewer, get more details, and also the interviewer provide hints on how to proceed. But yeah, so given this input array, so we need to check if there's a path that exists from 0 to 17. So going over the problem, the way they have said it, for the first, the value will always be 1. So let's just write it. So 1. So the next jump can be 0, 1, or 2. So we need to calculate, okay, from 1, if we make a jump, we cannot make a jump in the same direction. So if we make a jump of plus 1, so we see that there's no stone, so it's not possible. So if we make a jump of 2, there's a value 3. So the next jump, we say 2. Same thing, once we reach here, there are 3 possible jumps, 1, 2, and 3. So we need to calculate if from here we make a jump of 1 unit, so there's no stone, so it's not possible. If we make a jump of 2 units, we have this here, so we write down 5, so we can make a jump of 2 units. If we make a jump of 3 units also, it's possible because we reach the stone 6. So we write 6. So again, we go down here to the next value. So for 5, we can make a jump of 1, 2, and 3. So if we make a jump of 1 unit, we land at 6. So this is possible 1. 2 units, not possible. 3 units, we reach 8. So we write down 8. So again, 6. We have 2 possible combinations, 1 and 3. For 1, we have to check, is it possible we can make a jump of 0 units, or 1 or 2. So we make 0 and 1, no combination possible, but 2, we land up in 8. So I write down 2 here. Same thing, 3, we can make a combination of 2, 3, and 4. So if we make a jump of 2 units, we land up again in 8. We've already written it down. 3 units and 4 units, nothing is possible. So now we reach 8. From 8, we can make a jump of 1, 2, and 3, or 2, 3, and 4. So if we make a jump of 4 units, only then we'll reach 12. And from 12, we can make a jump of 3, 4, and 5. But if we make a jump of 5 units, we reach 17. So yeah. So this way we can calculate there's a path from 0 to 17. So yeah, essentially the concept we worked on here, we'll try to implement it. So the way we can implement it is by using a hash map. A hash map where the key is an integer value which represents each of these stones, and the value is the hash set. This represents the possible jumps you can make in order to reach that stone. So I know I went over it a little bit fast, but I'll try coding it and hopefully this will be clearer. So yeah. So first thing we're going to do is initialize this hash map. So what we're going to do is set the value of key to be the each stone and the value to be a set. So let's try that. So So yes, we have finally initialized this hash map. So they have said that from the first stone you can make a jump of only 1 unit. So we'll just initialize only the first value. So we'll put map dot and we'll set it to 0. So since then we know that the k plus 1 unit would be 1. So yeah, now that we have initialized the initial value, we're now going to do a traversal similar to what we did here. So we'll just traverse the stones, and then we'll traverse the possible jumps for each of these stones, and then we'll decide which possible combinations of jumps we can make from that to the next position. So yeah, so it'll be essentially 3 for loops. So first we'll do a traversal of all of the integers or the stones. For each of these stones, we're now going to traverse the list of jumps that are possible. So for that, we'll create another for loop. So the way to get the jump is just retrieve the hash set for each of them. So map.get. You can see an error here. So this essentially will give you the hash set for each of them. Now for the hash set, I think I've determined that the jump or the next jump can only be k minus 1, k or k plus 1. So for that we create another for loop. So for so they have said already that a jump can only be in the forward direction. So if this value that we have if it's less than 0, less than equal to 0, then we don't need to process it. So let's create a check for that. So if I 0, then just continue. So we're not even going to process it. Else what we are going to check is that for a jump, is it possible that the frog will land up in another rock? So for example here, if he makes a jump of 2 units, he will land up in 5. So we need to say which are the valid jumps that a frog can take. So for that, we'll just check if the value exists in the hash map. So if map.contains key. So this is a value, the stone represents the current value and the I is the jump that a frog is planning to take. So if it contains, the hash map contains it, then we just add it to the hash set inside of that. So map.get. So we just add the possible jump that a frog can take. So essentially we keep traversing down this integer array all the way to the end. And once we reach the end, the only thing we need to check if the last stone, it has a non-empty hash set. Because that means there was some combination. So here they're not asking us to find the smallest or easiest way to reach. They're just saying, is it possible to reach all the way to the end? So as long as a value is set for this hash set, I think there's a path. So yeah, let's just return whether this is a non-empty. So first thing we do is retrieve the value for the final stone. So stones. So we just checked in the end. So yeah, recapping, first thing we did was we created a hash map where the key is the key is the stone and the value is a hash set. We initialize it in the beginning by setting the value equal to 0 because I think they've said the first jump must be of 1 unit. And next step we are going to do is create 3 for loops, and we'll just calculate for each of these stone what are the possible jumps, and we'll keep adding it into the hash set. At the end, we just check if the final stone is a non-empty hash set. So let's try running the solution. Oh, I think this is the wrong. Okay, so I should have said map.get stone 0. Yeah, so essentially I didn't initialize it correctly. So I just needed to say add this value to the hash set. Let's try running it. Oh, I didn't spell this correctly. And I should have put I here. All right. So yeah, the two use cases have passed. Let's try submitting the solution.